right, let me share my screen and we're going to do section 11.2, which is continued geometry terms. You're going to have one assignment over section 11 and 2. I think it's just like 9 questions total. So I'm going to go through these kind of quickly. First, polygons and symmetry. So that's the topic of 11.2. So let's jump in and talk about curves. Curves, shape. A simple curve is a curve that does not cross itself. Starting and stopping points may be the same. Simple curve doesn't cross over. A closed curve is a curve that starts and stops at the same point, and a polygon is a simple closed curve with sides that are lines. A convex curve is a simple closed curve with no indentations, and a concave curve is one that is not convex. So I think it's best to just look at examples. So is this a simple curve? Yes, because you see simple is a curve that does not cross itself. So as you see in this first example, this is a curve. It's not closed, but does this curve ever cross itself? No, this would cross itself, so that would not be simple. This is simple because it doesn't cross itself. This is also simple because it doesn't cross itself. This is simple because it does not cross itself, but then it's also closed because you see that its starting and stopping point, no matter where you start or stop, it connects. So basically it's connected. So this closed means that it's connected. And then concave versus convex. So concave means that it comes in. So like this part right here, that's a place where it comes in, that's a place where it comes in. And so if it comes in, it's concave. If it does not, then it's the opposite of that, which is convex. You're going to be either this or this if you're a closed curve. Okay, so if you're closed, you're going to be convex or concave, but you're not going to be both of them. Let's see. So this is a curve, but it's closed, but it's not simple. So here's an example of something that, see, it is closed, it's not opened. This would be open, but it is not simple because it crosses itself. Okay, this one is simple closed. It's a polygon. The reason why it's a polygon is because it's made up of line segments. So that means all the sides are like this versus this would not be a polygon if one side had like a curve. Okay, so polygon means that all the sides are line segments, they're straight. Convex versus concave, remember concave means it has a place where it comes in. This one does not come in on itself, so that's why it is convex. Every simple closed curve separates the plane into 3 distinct disjoint subsets: the interior of the curve, the exterior, and the curve itself. So interior, exterior, and the actual curve. And then we also see the vertex definition. Here's that point and the side. These are names of polygons. You might be familiar with them. Notice they all end in -gon, okay? And then the beginning, the prefix, these guys, origin from, related to Latin. So tri means 3, quad means 4, pent means 5, hex is 6, hept is 7, oct like octopus 8, non is like 9, des is like decimal system, or December, it's the 10th one, a decimeter, hen decagon. This one is interesting, that's 11, and dodecagon is 12. Interior angle is one on the inside. Exterior would be along the side of a polygon if you continue it. So let's look at this here. So you see the interior angle is inside the polygon itself. This is an interior angle. An exterior, this is an interior angle. An exterior angle is if you were to continue out the side of any of these guys in any direction. An exterior angle, so if this is the interior one, this would be the exterior one. Congruent is this right here, this symbol. It looks like an equals sign with a little squiggle on top. That means congruent. That means they have the exact same shape and the exact same size. Okay, so congruent means same size and same shape. So these are congruent line segments. They're equal. These angles are both 108 degrees, so they are said to be congruent. Regular polygon. Okay, so if you see the word regular, regular means something very special. It means that all sides and all angles are equal, okay, or congruent, all the same. So regular pentagon, if this was 5, these guys would all be 5. And then if this was 7, these would all be 7. So regular has to do with the fact that they are equal to one another. Drop my pen, sorry about that. Let's move on. Right triangle. Okay, so different types of triangles. A right triangle has a right angle. An acute triangle has all acute angles, which means, if you remember from last lecture, acute means it angles less than 90 degrees. An obtuse triangle has a one angle that's obtuse. It only can have one because altogether the sum of these angles must be 180 degrees. That's just a side note. So if one of them is obtuse, the other two have to be acute. So they can all be acute. One can be right or one can be obtuse. We can also define triangles by their side lengths. Scaling means that they're all different. I kind of remember it as scaling. A lot of times it looks like it's leaning over, not always, because it can be a right triangle as well. Like this is a classic example of a right triangle, 3, 4, 5. These are all different side lengths, so that would also be scaling, even though this is a right triangle. But these dashes mean that they're not the same. So whereas these dashes mean they're both marked with one dash, which means both of those sides are the same. Isosceles has two, these two can help me. I know it's an I and an L, but also remember there's two that are the same. Or you can look at the two S's right here, but like two sides the same. Equal, well, that has the word, it has that equa, which is equal. So hopefully that helps you remember same. And so since they're all the same sides length, they're also all the same angles. It'll all be 60 degrees. So classifying angles, triangles by sides, I'm sorry, by angles, and then also by sides. Now let's talk about quadrilateral. Quad means 4. This means 4, so 4 sides. So there's several different ways to draw a shape that has 4 sides. One of them is called a trapezoid. This definition is it says it has at least one pair of parallel lines. So these two are parallel. These two are not. Notice it says at least. So it could be a rectangle, like a trapezoid has only this one pair, at least one, whereas a rectangle has 2 pairs of parallel, these would be parallel, and also these would be parallel. So a rectangle would also fit under this definition because it does have at least one pair. A kite has 2 adjacent sides congruent and the other 2 also congruent. So notice it kind of looks like a kite. Like if I was to rotate this shape, it would look like a kite for you, right? So 2 sides next to each other. Adjacent means the ones next to each other. Isosceles trapezoid are congruent base angles. Parallelogram, opposite sides are parallel. A rectangle has one right angle. A rhombus has a parallelogram with 2 adjacent sides congruent. So basically it's all 4 sides are equal to one another and their opposites are parallel. A rectangle has 2 adjacent sides congruent, but also it's a right angle, sorry, a square. So a square has equal sides and equal angles. So what does this look like? This helps a lot to see this chart. So there can be lots of different kinds of polygons. This is not an all-inclusive chart of polygons, but it's telling us, okay, we could have 3-sided shapes or we could have 4-sided shapes. And I could keep going and be like, oh, okay, we could have 5-sided shapes or 6-sided shapes. We're just going to talk about the triangle and quadrilateral. But triangles, excuse me, and we'll classify it by sides. Scaling, remember, means all sides are different. So none of these are the same, or it can look like this, just all sides are different. Isosceles means that at least 2 sides are the same. Equilateral means all 3 are the same. So equilateral also would be an isosceles because it has at least 2 sides that are the same. Quadrilateral just means there's 4 sides. So if you have a kite, if you remember, has these 2 the same and these 2 the same. A rhombus has all 4 the same, but kind of still looks like a shifted square, unlike a parallelogram that is all sides equal. The opposite would be a trapezoid. So here's an example of a trapezoid. A trapezoid, if you remember, has at least one pair of parallel lines. So you can have an isosceles trapezoid, which is like the one I just drew, where these base angles are congruent. Parallelogram would also be a trapezoid because does it have at least one pair of parallel lines? Yes, but to be a parallelogram, it has to have two pairs of lines. And then from parallelogram, you can also be a rectangle because a rectangle has opposite sides parallel, but it also has opposite sides equal and it has 90-degree angles. From a parallelogram, you can also be a rhombus because these opposite sides are parallel. It's just that all the sides are equal. And then a square is a quadrilateral, and a square is a rhombus, and a square is a rectangle, and a square is a isosceles trapezoid, and it's a parallelogram, and it's a square is all of these things. A square, because let's talk through why. All equal sides, all equal angles. Is it a quadrilateral? Yes. Is it a trapezoid? Yes, because at least one pair of parallel lines. Is it a parallelogram? Yes, because it actually has the two pairs of parallel lines. Is it isosceles? Yes, because the base angles are congruent. Is it a rectangle? Yes, it has a 90-degree angle. Is it a rhombus? Yes, because it has the four sides congruent. Is it a kite? Yes, because adjacent sides are also congruent. They happen to all be congruent. So a square actually is all of those terms. Hopefully that makes sense. I know I went through that quickly. Then another part of geometry is thinking about symmetry. So line of symmetry is if you could cut something down the middle and it's the same on both sides, like a butterfly is a really classic example. There's not always just one line of symmetry though. Like a circle has infinite lines of symmetry because you could cut it any direction and pull it over and it would be equal. So here's showing you how there's different lines. Like this one has 3 lines of symmetry. This one has 1. This one has a lot of lines of symmetry. This one has 1. How many lines of symmetry does this have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This one just has 1, this one has 2, and this one has none. Rotational symmetry is if I'm able to take something and turn it around and it would be the same. Okay, so a triangle has rotational symmetry because you take it and you rotate it, it's the same. Not all triangles, ones that, like this one, is equilateral. This would be rotational symmetry as well, because if you notice all these, if you just rotate it, they all line up. So that is rotational symmetry. So this one has rotational symmetry. To figure out the degrees, I would just divide 360 by 5. So 72. This one, 1, 2, 3, 4, 5, 6. So you would take 360 and divide it by 6, which gives you 60. So every 60 degrees you rotate it, it will look the same. This one, you have to rotate halfway around. Like because it has these 2 lines of symmetry here, and if I take it and I rotate it halfway around, it would be the same. So that's 180 degrees is halfway around the circle because the whole circle is 360 degrees. Point symmetry is if you have one single point and you rotate around that point, that it would be symmetrical. So this guy has 1 line of symmetry and no turn symmetry. So this is an example of something that 1 line of symmetry, but if I turn it, I have to turn up the full 360 degrees before it looks the same. So it does not have rotational symmetry. So I know that was fast. I hope that this helps though. The assignment is not too difficult. Please reach out to me if you feel stuck or you need help. I am here to help. I hope you had a great spring break, and please let me know if you have questions.